Before we begin with the spectrophotometer, we must prepare the experiment. Using the beaker of solution, transfer enough solution into the cuvette. However, make sure that the cuvette does not overflow. This means filling the cuvette to the line. Repeat this step for every cuvette until you result in 3 cuvettes of solution as shown here. The clear cuvette is water that acts as our blank. Now it's time to use the spectrophotometer. The spectrophotometer is a device that measures how much light a substance absorbs. It is used by passing light through a sample to determine its concentration. When using a spectrophotometer, we can collect 2 types of data, quantitative and qualitative. Qualitative data describes the pattern or appearance of the absorbance spectrum. For example, seeing which wavelengths are absorbed more or less helps us understand the properties of the substance, such as its color or chemical structure. Quantitative data is numerical. For example, the absorbance value at a specific wavelength. This tells us exactly how much light a solution absorbs and is used to calculate things like concentration. Just a note, it is important to scan across all wavelengths instead of measuring just one. There are 2 main reasons for this. First, scanning the full range helps us find the lambda max. We're going to talk more about this later, but it's the wavelength at which a substance absorbs the most light. Knowing the lambda max is important because it gives the most accurate and sensitive readings for concentration. Second, scanning across all wavelengths helps identify unknown substances. Different compounds have unique absorbance patterns, so their spectra can act like fingerprints. To begin using the spectrophotometer, you must put in the blank, then zero the machine. This is so that it cancels out any absorbance from the solvent or the container, ensuring that the only absorbance that is measured is of the actual sample. Once the machine is zeroed out, you are ready to put your samples in. Wipe down the sides of the cuvette, place it in the machine, close the machine, then press run. Once the absorbance is given, write that number down in your notebook. As you can see, a graph is formed in order to determine the optimal wavelength. This optimal wavelength, also known as lambda max, is found at the highest peak on the graph. Lambda max is the wavelength of light that a substance absorbs the most. In this experiment, the lambda max was at 545 nanometers. The Beer-Lambert law helps us understand how much light a solution absorbs. Here's the equation. In this equation, A stands for absorbance, which is how much light the solution absorbs. Epsilon is the molar absorptivity, a constant that depends on the substance in the wavelength of light. C is the concentration of the solution in moles over liters, and L is the path length of cuvette, which is typically 1 centimeter. There's a direct relationship between absorbance and concentration, meaning the higher the concentration, the more light is absorbed. Before measuring absorbance, it is important to zero the spectrophotometer using a blank. The blank contains everything except the substance being tested, usually just the solvent. This step ensures the machine only measures the absorbance of the actual solute. If you skip this step, your absorbance readings will be too high because it would include the absorbance from the solvent in the cuvette, making your results inaccurate. Now we are going to perform the experiment again. Wipe the cuvette with a wipe to make sure that nothing remains on the outside of the cuvette. Open the lid to the spectrophotometer, place the cuvette in, close the lid, and press run. Repeat this for all the other cuvettes. Always make sure you record your absorbances after they are measured on the spectrophotometer. The first absorbance was 0.2310, the second absorbance was 0.2425, and the third absorbance was 0.1045. Now that the experiment is done, make sure you clean every piece of equipment that you used with soap and water.